Okay. I'm hearing a bit of echo.
That's probably me.
Let's try that again. Nope, there's echo for sure. Oh, now it's gone.
Roger, I think you need to mute. Yeah, I think Roger needed to mute.
Okay, sounds good. All right. Good afternoon. I'm Kayvon Stousen, Chair of the Awards and Facilities Committee. Committee members include ANF Committee Vice Chair Suresh Babu, Roger Beachy, Aaron Dominguez, Juan Gilbert, Jeffrey Isaacson, Matthew Malkin, Julia Phillips, and Merlin Theodore. Welcome to today's open committee meeting. Today we'll receive context from NSF for the renewal of the National Radio Astronomy Observatory, or NRAO, Operations and Maintenance Award. You may remember the board approved a request to increase the cost cap on the previous Operations and Maintenance Award at our February 10th meeting last year. After NSF's presentation, we'll open up for Q&A by ANF members, and in particular, lead discussants Jeffrey Isaacson and Juan Gilbert. For all the committee members, the materials associated with today's meeting are available in the ANF Committee SharePoint board book. So with that, I'll now turn to Chief Officer for Research Facilities, Linnea Avalon, who will give a brief presentation before turning the floor over to our presenter.
Thank you,
Linnea.
Kayvon. Good afternoon, everyone. So as Kayvon said, we're here today to present to you a context item on the National Radio Astronomy Observatory, or NRAO, and this is related to the Operations and Maintenance Award renewal. NRAO was NSF's first federally funded research and development center, or FFRDC, established in the late 1950s. Over the ensuing 7 decades, NRAO has stewarded world-class observational capabilities across the radio portion of the electromagnetic spectrum. NRAO's ongoing technological innovation has positioned the facility at the forefront of international radio astronomy, setting the global standard for observational capabilities and scientific productivity. The facility trains the next generation of radio astronomy scientists and engineers while fostering broader STEM education through comprehensive public engagement programs. Technologies developed at NRAO have demonstrated a significant cross-sector application, and the observatory has established productive partnerships across academia, industry, and federal agencies to advance these capabilities. And as you'll hear in the presentation, NRAO facilities play important roles in advancing administration priorities and addressing national security concerns. The NRAO program officer is unable to join us today, so the presentation will be given by Dr. Luca Rizzi, an optical astronomer who's serving in a supervisory role in my office. Dr. Rizzi is joined by Dr. Harshal Gupta, a program officer in the astronomy section of the Directorate of Mathematical and Physical Sciences, and Dr. Ashley Vanderlei, a senior advisor in the Office of International Science and Engineering. Both Harshal and Ashley are radio astronomers who work closely with the NRAO facilities. Until recently, Harshal oversaw the Green Bank Observatory Award, and Ashley helps with all aspects of oversight of the Very Long Baseline Array and the Next Generation Very Large Array Design Project. With that, I'll turn it over to Luca to give the presentation.
Thank you. All right, sounds good. Good afternoon, and thank you for the opportunity to present this context item on the renewal of the National Radio Astronomy Observatory, or NRAO. Over the next few minutes, I'd like to discuss with you why radio astronomy matters, what NRAO is and what it does, why it is so well aligned with the administration priorities, and what the path forward looks like as we approach the end of the current award. Next slide. I'll start with a few remarks on the scientific background. Every part of the electromagnetic spectrum tells us something different about the universe, from gamma rays at the high energy end all the way down to radio waves. Radio photons are produced primarily by the cold universe, gas clouds, dust, the faint afterglow of the Big Bang itself. These are all best seen in radio. And because light from the most distant objects in the universe is redshifted as it travels toward us, those objects that began their lives emitting visible or ultraviolet light often arrives at our detectors as radio waves. In that sense, radio astronomy is our window to the deep cosmos. But radio doesn't work in isolation. It's most powerful when combined with data from other parts of the spectrum, from ground and space-based optical, infrared, and X-ray observatories, and with entirely different managers, like gravitational waves and high-energy particles. Together, this gives us a complete and detailed portrait of the astrophysical objects we observe. The images on this slide illustrate two extraordinary examples of what radio astronomy has made possible. On the top, you see a protoplanetary disk, a young star surrounded by a swirling disk of material in which a planet is actively forming. And around that newly formed planet, you can see the beginning of moons. That is a first. No instrument before NRO has had a resolution or sensitivity to capture that. The second image shows complex organic molecules, prebiotic molecules, detected in star-forming clouds by ALMA. These are the kinds of molecules that may have seeded the conditions of life on Earth. Beyond the science itself, NRO operates as an open access model, on an open access model. Any qualified researcher can apply to use these facilities. By providing access to a wide user base, NRO ensures the best science gets done, and crucially, it trains the next generation of scientists and engineers. Next slide. So what exactly is NRO? It is a constellation of world-class facilities bound together under a single management structure and a single vision of scientific excellence. At the international flagship end, there is ALMA, the Atacama Large Millimeter and Submillimeter Array, located at nearly 16,000 feet of elevation in the Atacama Desert in the north of Chile. NSF, along with Canada and Taiwan, is responsible for 37.5% of this partnership. It is the most powerful radio telescope array ever built for observing a millimeter wavelength. Closer to home, the Central Development Laboratory in Charlottesville, Virginia, serves as the technological engine of the entire enterprise, designing, developing, and maintaining the instruments and electronics that make these observatories work. In West Virginia, the Green Bank Telescope is the largest fully steerable telescope, in fact, the largest fully steerable objects on Earth. It operates as part of the Green Bank Observatory, which includes additional instruments on the same site. In central New Mexico, the Very Large Array, VLA, is an interferometer made of 27 dish antennas spread across the high desert plains, capable of imaging the radio sky in extraordinary detail. And the Very Long Baseline Array, the VLBA, takes the concept of interferometry to its logical extreme, with 10 antennas stretching from the Virgin Islands to Hawaii, creating the higher resolution centimeter wave facility on Earth. NRO is also responsible for administering the National Radio Quiet Zone, centered on Green Bank, a protected region that shields our most sensitive instrument for interference, and coordinating spectrum management activities for all other NRO sites. And as I'll discuss shortly, NRO is already working on what comes next, the next generation Very Large Array. Next slide. NRO's activities are not just scientifically excellent. They are directly aligned with several of the administration's core priorities, and I would like to highlight 5 of them. First, critical technology. Working with an industry partner, NRO is developing an advanced cryocooler with no moving parts. That means less maintenance, lower energy consumption, and dramatically reduced use of liquid helium. The application extends far beyond astronomy. This technology is directly relevant to MRI machines used in hospitals around the world. Second, advanced manufacturing. The instruments needed for next generation radio astronomy require cutting-edge fabrication techniques, precision machining, novel material, miniaturized electronics. These capabilities are directly transferable to communication satellites, quantum computers, and other high technology industries. Third, future computing. The data volumes expected from modern and future radio observatories are staggering. NRO is at the frontier of applying AI and advanced algorithms to data acquisition, processing, and storage. capabilities that will have broad application across science and industry. Fourth, advanced communications. NRO is actively contributing to next-generation telecommunications technology, including the development of techniques to detect and mitigate interference from radio signals, a challenge that affects every user of the radio spectrum, from broadcaster to emergency services to the military. And fifth, securing national defense. NRO's radar capabilities provide data relevant to planetary protection, space situational awareness, and the characterization of objects in low Earth orbit and beyond. Next slide. NSF role in radio science and astronomy stretches back more than 7 decades, and it has produced the world-class facility we support today. The story begins even before NSF itself. The National Radio Astronomy Observatory was conceived in parallel with NSF's founding, and when it was formally established in 1956, it became NSF's very first federally funded research and development center, FFRDC. At the time, NRO consisted solely of the Green Bank Observatory in West Virginia. That is where this all began. NRO headquarters relocated to Charlottesville, Virginia in the early 60s. 2 decades later, the Very Large Array came online in central New Mexico in the late 70s, a project that transformed radio astronomy and produced some of the most iconic images in the history of astrophysics. And in the late 80s, the Very Long Baseline Array extended our reach still further. This is a 70-year investment by NSF, and it has paid extraordinary results in scientific knowledge, technological innovation, and the training of generation of scientists. Next slide. The organization that has managed NRO from the very beginning is Associated University Incorporated, AUI. The image on the left of this slide shows the signing of the original agreement that created the FFRDC and established AUI as its managing partner. Their relationship has endured for nearly 7 decades, and it has been a productive and effective one. The most recent and perhaps most spectacular addition to this portfolio is ALMA. Perched at nearly 16,000 feet across the sea level in the Atacama Desert, ALMA's 66 antennas represent a triumph of international scientific collaboration and engineering. The image on the right shows the array in its operational configuration, a sight that still takes the breath away. AUI is responsible for all ALMA staff based in Chile, managing an inherently complex international operation with professionalism and excellence. It has been an outstanding partner in every sense. Next slide. NRO does not operate in isolation. It has cultivated a rich ecosystem of partnerships across academia, the private sector, the government, domestically and internationally, and only a small subset of these are shown on this slide. In academia, NRO is a core member of Cosmic AI, NSF's newest AI institute, led by the University of Texas at Austin. This center is developing novel AI tools and techniques for application in astronomy, tools that will ultimately have value far beyond the field. On the private sector, NRO provides downlink and data acquisition support for Intuitive Machines' lunar exploration missions. The VLBA's role here was critical. It was VLBA data that allowed engineers to reconstruct the image of the IM lander laying on its side after landing, an image we would not have had otherwise. NRO is also working with satellite companies to develop novel techniques for avoiding interference from space-based internet constellations. Internationally, the ALMA partnership itself is a model of scientific diplomacy, bringing together Europe, Japan, Canada, Chile, Taiwan, and South Korea. An international interest in the future NGVLA is growing. Mexico, for example, is funding site identification and characterization work for NGVLA antenna location. On the government side, the US Naval Observatory, among others, has been a vital partner in operating the VLBA, providing notionally 50% of annual operation and maintenance costs. In reality, USNO support has exceeded that level considerably, contributing more than $75 million over the past decades to the upkeep and improvements. Next slide. NRAO has been an excellent steward of radio astronomy observatories from the very beginning, and the metrics bear this out unambiguously. NRAO is recognized globally as the gold standard in radio astronomy and radio science, a trusted partner and the go-to source for advice and technical support for institutions worldwide. By late 2025, data from NRAO Observatory had surpassed 1 million citations in the scientific literature. 1 million. The number continues to grow. NRAO data appear in the second highest number of astronomical publications of any observatory on Earth, trailing only the European Southern Observatory, and not by much. 10 years into operation, ALMA continues to set record for the number of proposals received and the number of observing hours requested, more than any other astronomical observatory or instrument in history. And at the Central Development Laboratory, NRAO continues to push the boundaries of what is technically feasible, delivering bleeding-edge technology that enables science that could not be done any other way. Next slide. Thank you. Let me turn to some science outcomes, and I want to start with what I consider the most iconic astronomical result in the past decades, perhaps of the modern era. The Event Horizon Telescope EHT collaboration produced the first ever image of the shadow of a supermassive black hole, the one at the center of the galaxy M87, 55 million light years away. That image, the orange ring you've almost certainly seen, is simultaneously a triumph of observational astronomy and a vindication of general relativity. It is exactly what Einstein's theory predicts. ALMA was an essential component of the Event Horizon Telescope interferometer. The two images on the slide tells the story. The image on the right is what the EHT would have produced without ALMA. The image on the left is what we actually got with ALMA. The difference is extraordinary. To put the resolution in perspective, 50 microarcseconds is equivalent to resolving an orange sitting on the surface of the moon from Earth. That is the highest resolution image ever obtained by any astronomical instrument. Next slide. The second science highlight I want to share is much more recent, and it points toward capabilities with significant national relevance. NRAO has been conducting a technology demonstration using a radar transmitter installed on the Green Bank telescope. The transmitted signal is received and processed by VLBA antennas, effectively turning this pair of instruments into a radar system of extraordinary power. The prototype transmitter operates at 700 watts, the power equivalent of a household microwave oven, and yet the images it has produced are stunning. The background image on this slide is the Tycho crater on the moon at 5-meter resolution. The small image on the left is the Apollo 15 landing site at 1.25-meter resolution. This technology is being developed in partnership with Raytheon. The applications are significant. In planetary science, this capability allows us to study the surface and subsurface of solar system bodies in unprecedented detail. For space situational awareness, it provides a tool for tracking and characterizing objects in Earth orbit and beyond. And for planetary defense, it enables the detailed characterization of potentially hazardous asteroids, giving us the information we need to assess and, if necessary, respond to the threat they pose. While this is just at the demonstration level, it is the kind of dual-use capability, scientifically valuable, nationally relevant, that exemplifies what NRAO does at its best. Next slide. Yeah. Thank you. Looking ahead, NRAO's future is full. There are ongoing upgrades to ALMA's instrument and correlator computing system, as well as preparation for a more comprehensive refresh of ALMA that includes projects such as the wideband sensitivity upgrade and a project to increase the sensitivity by a factor of 10. Updates to the VLBA will ensure its continued relevance for both science and USNO's mission support. And a range of smaller projects, from sky surveys to data accessibility initiative, will keep the observatories productive and inclusive. But the centerpiece of NRAO's future is the next generation Very Large Array, the NGVLA. The figure at the center of the slide shows the projected location of the antennas, stretching across multiple US states and including locations in Mexico and in Canada. The project is currently in development phase and is being positioned for entry into NSF major research equipment and facilities construction queue. When built, the NGVLA will replace both the VLA and the VLBA with a transformative new facility, more antennas, broader geographic distribution, dramatically improved sensitivity, and capabilities that will keep the United States at the forefront of radio astronomy for decades. The NGVLA is not just a scientific investment, it is a STEM investment, a magnet for talent, a driver of technological innovation, and a training ground for the scientists and engineers of tomorrow. Next slide, and this is our last slide. Finally, a word on where we are in the process. So the current 10-year cooperative agreement expires at the end of fiscal year 26, September 30. We're now in February, which means we are in the final stretch of the review and renewal process. The process will culminate at the NSB meeting in May, after which the team will develop the new cooperative agreement and the associated cooperative support agreements over the summer, with a goal of seamless transition to a new award beginning October 1st. Thank you for your time and attention today. NRAO has been a source of extraordinary scientific achievement, technological innovation, and national capability for nearly 70 years. Its next chapter, anchored by the renewal of this award and the development of NGVLA, promises to be every bit as remarkable.
Thank you very much. I'll now turn the floor over to the board members who will serve as the lead discussants for today's context item, Jeff and Juan. After they kick us off, they will open the floor for the broader ANF committee and other board members who may be joining us to ask questions.
Well, thanks, Kevin. I think I'll kick it off and turn to Juan in a moment. We have probably about 15 minutes, I think, on the schedule for Q&A. So I would ask folks to hit the raise hand button. I'll do my best to see that with 27 participants here on this call. But let me start it off by first thanking Linnea for her introduction and Luca for the presentation. Very well done. Could you say a few words about the process leading to renewal? The cooperative agreement was competed 10 years ago. This time, was there a dear colleague letter, any collection of information, a comprehensive review? You did mention a review. What was the process that NSF used to get advanced to this point for renewal?
Yeah, so we have an internal process that we go through every time an award is coming to its end, usually about 2 years before that point. We gather our internal resources and evaluate whether we want to propose competing or renewing an award, or divesting of part of the facility. So we use that process. It involves looking at community input through consensus documents and advisory committees, looking at the performance of the awardee through various business processes, looking at other community consensus reports, such as things from the National Academy, and then putting forward a recommendation to our internal facilities governance board. That board then makes a recommendation to the NSF director about the course of action. So in this particular case, the recommendation that came out of mathematical and physical sciences was that the award should be renewed, and both the facilities governance board and the director agreed with that.
Great, thank you. Juan?
Yes, thank you. Do you anticipate changes to the partnership involvement from the private sector and international collaborators in a short or midterm?
Give us a second. We're getting somebody to respond.
Sure.
Harshal,
sure.
go ahead.
I can start, and then Ashley can. All right. So yeah, partnerships are constantly evolving depending on the needs of the community and the observatory. So this is an active endeavor of the, for example, at Green Bank, we have 25% partnerships from non-NSF partners, and we evaluate them continuously, and we've managed to keep those. And then at USNO, we have a 50% partnership with at the VLBA, we have a 50% partnership with USNO, and at ALMA, we have a 37.5 partnership with international partners. 37.5 with NSF and 62.5% with international. So there are, these are not static, but they've been stable for a long time, and they continue to evolve as we, as things change with the partners, or we embark on new initiatives and new projects. So all of this is continuously evolving, but we've had a pretty stable slate of partners for a while. Ashley, please take it away.
Yeah, thank you, Harshal. I might just add a couple other comments. I do think the partnerships with regard to ALMA are probably going to be somewhat similar, but that is always looked at the ALMA governance board meeting sort of on an annual basis. But I think sort of that distribution would look similar with the European partners, Taiwan, et cetera. One large area for expansion when it comes to international partnerships will be with the next generation VLA, where Mexico and Canada have already expressed a lot of interest, and there's some other discussions ongoing with some international partners related to that. And then I also wanted to mention with the VLBA, of course, there's a very strong partnership with the United States Naval Observatory that we do expect to continue sort of in a good 50-50% type of partnership moving forward. And then private, you mentioned, I think there's a lot of opportunities there as well. Luca referred to this in the presentation. There's been a lot of partnership between NRAO and private industry, whether it is Raytheon with the radar development at the Green Bank Telescope, and also in the spectrum management area with a number of commercial satellite companies that NRAO has been working with directly. So we do expect all of that to continue and probably also increase as this award is renewed.
And the follow-up to that, I'm not sure if there's something you guys thought about, so this is somewhat out of left field, but is there a partner, for lack of a better way of describing it, a non-obvious partner out there that should be considered as a future partner? In other words, is there industry or something that's not connected and has not been connected since the inception of the project? Given the state of the art, the advancement of technology and AI and all the other things that are happening, are there other opportunities for partners that are non-obvious given the history of this award that may exist today that did not exist years ago?
Harshal, go ahead.
So first of all, the observatory management does seek out, is always on the lookout for partnerships, and sometimes they grow organically through interactions with the community, and sometimes they work. Often they work with us, people like myself and Ashley, to identify other opportunities, and we can bring those to them as well. One example is the NRAO is playing is a key member of the Cosmic AI institute that's supported by NSF. But you know, the non-obvious partners, you know, it's not immediately clear, like what, you know, things can come out serendipitously. I think the Raytheon effort was also quite organic, where Raytheon wanted to test their capabilities, and there was a need for exploring additional capabilities with the GBT and VLBA. So that came about, and then similarly, there's many efforts underway at the Central Development Laboratory, and these so-called non-obvious partnerships mainly come about through interactions with community. Anyway, Ashley, you want to add something?
Yeah, a couple areas, maybe it's not non-obvious, but I do think the upcoming opportunities, for example, with Artemis, is very exciting with NASA, and to see what possibilities NRAO might have to be able to support the Artemis mission and the continued push for the United States to really expand in space superiority. So I think that's an opportunity, NASA and the whole ecosystem around that, including commercial space, right, which is a very large growing sector in the United States. Also wanted to mention, just in terms of maybe some other unexpected partners, as Herschel mentioned, at the Central Development Lab, they've done a lot of incredible work. For example, their low noise amplifiers, that has kind of spread into industry. And they're also beginning to look at some research and development in some very interesting areas. So for example, with the increasingly congested radio frequency spectrum, traditional notch filters raise the noise across your whole broadband, so it's not fantastic. So they're starting to look at development of superconducting tunable notch filters. So that would be very helpful, for example, for our receivers. But again, you can imagine fantastic partners and possibilities for commercial partnership there as well.
Ashley, one more. Can I add just a very quick comment? You're the expert on this, but there's been a coordination effort with satellite companies to reduce interference. So coordinating the board, coordinating their passage, coordinating our observations with passage of the satellites above our observatories. That's one way to really work with them, and Ashley can speak more about this.
Yeah, I'll just
so
comment.
Those are the non-obvious.
Yeah, so this has been a really. Oh, apologies.
If you could, yeah, 30 seconds. I want to make sure that other board members get an opportunity to ask questions before we break. So please respond.
Yeah, I was just going to comment, it's an area in wireless communications. A lot of the spectrum management has been manual for many years, and so there's a huge opportunity to grow to dynamic sharing that kind of helps everybody coordinate better. And so NRAO has been at the cutting edge of this in terms of actually doing dynamic automated coordination. So that's, yeah, just a specific example that Herschel described. Thank you.
Okay. Bev, did I see your hand come up?
No, I was going to say that Roger had a question in the chat, but Linnea answered it, so we're good.
Oh, okay. Any other questions from the board committee? Well, there's Aaron. Go ahead, Aaron.
Sorry, Jeff. Yep, not used to Microsoft Teams yet, and apologize for my informal appearance. My Jeep broke down today, so had to deal with that. Ashley and others. So you mentioned the Artemis mission. Tell us more about other kind of like dual use, applications for this awesome facility for national security.
Aaron, I think there's relatively little that we can say about that in an open session.
Yeah, I'm not asking for anything classified here. Just what are the capabilities of this facility for the United States other than what you've raised so far?
Ashley,
guess
would
I'll
you take
start.
that? Yeah.
Yeah,
Go
just
ahead.
very quickly. So I think one thing we could say in this session is a little bit more about the USNO partnership with the 50% observations that they do with the Very Long Baseline Array. So they do observations of distant black holes and quasars all over the sky. And this provides fundamental information on the celestial reference frame and Earth orientation parameters, how the Earth actually rotates and wobbles, and is able to tie that to the terrestrial reference frame and provide input into the international celestial reference frame. And the VLBA actually provides about 70% of the data that goes into the international celestial reference frame, which is critical to all kinds of economic things worldwide and kind of underlying GPS. So I think that's a very important thing for the US economy broadly and also for the global economy.
Thank you.
Hey, Julia?
Yes, just follow two things. One is just to follow up on what Aaron just asked about. I think it would be appropriate for, obviously not on an open line, but for the members of the science board that do have access to more sensitive information to understand in more detail what the national security, impact of these facilities are. So I'm just putting that out there as a request. And then the other question is, as you well know, we are not the only ones who are argue that we are and arguably preeminent in many areas of science. I'm wondering what the state of play is in radio astronomy writ large, particularly China, but other countries as well.
Anybody want to take that?
I have some pretty
Marshall, go ahead.
strong opinions. Well, I just very briefly, it is a very good question. I have some strong opinions about it. I spent a fair bit of time at China's, premier competition in radio astronomy. They poured, a staggering amount of resources into it. It's very showy, and it just doesn't compete at all with anything. It doesn't touch it. I mean, after all these decades and all that money, it was a little bit of a step ahead of Arecibo, which was back in the 60s. I was amazed. There's no other country, certainly not China, but Europe, anywhere, that really can touch the capabilities and what the science is. This is just a total leadership. I mean, the United States, which means NSF, really just owns it. Anyway, I don't know. That's what you want to.
Oh, thanks. Okay, that might be true, and I want to hear your response. But the other question is, what are the derivatives of development in different places? In other words, is the gap closing or whatever? Okay, over to you all.
Yeah, so if I could address that, there are two. Certainly, we need to consider our capabilities in the international landscape. And as Matt pointed out, ALMA is the world-leading observatory. I mean, you can see the stunning results that are coming out from in terms of understanding star and planet formation and even fundamental physics. And the VLA is doing an excellent job, and the GBT is contributing. So there are many things. So the premier facilities currently are ALMA on the world stage. And then going forward, the NGVLA development is going to maintain, if it should go forward, it will maintain our leadership in radio astronomy. And it also connects very well with the international landscape. ALMA doesn't operate in isolation. Everybody uses it, and we as in the United States was crucial to developing that capability. If NRAO and NSF hadn't taken the lead on that, there would be no ALMA. similarly, NGVLA would be at lower wavelengths in the centimeter band, it would provide the best capabilities there are, like unprecedented capabilities, and it would. You've probably heard of the square kilometer array that's been developed in Europe. NGVLA will directly complement and exceed some aspects of SKA. So we need to maintain that level of leadership, and we are the only NRAO is one of the only places that can do that, and it's clear that they're the preeminent observatory in the world. And I can say that without any ego or bias.
We're running short on time. There are no other pressing questions. Let me ask the last one. Luca, you had mentioned during your presentation multi-messenger astronomy. To what extent is the continuation renewal of NRAO playing a prominent role in developing the data repository, including timestamps and the like, or is that moving along a separate path within NSF and NASA? Over.
NRAO has some plans that are described in the proposal about expanding their archive, expanding their reach into AI capabilities, and integrating with the largest landscape of astronomical data. So it is an integral part. It is extremely important. And it does play a crucial role in the understanding the properties of astronomical object over the entire spectrum. So yes, it is absolutely important. Plays a critical part.
You anticipate funding lines within the FFRDC cooperative agreement for that specifically, or is that just something that will kind of move forward under its own momentum?
I think it will have to be discussed on a yearly basis based on the availability of fundings. But we will work with the project to get a prioritized list of which one of these upgrades is the most crucial to maintain the competitiveness of this facility. So yes, it will be part of the discussion or in preparation for the award, which will happen in the second half of the year and then yearly for the next 5 years.
All right, well, seeing no other hands, I thank the respondents for all the answers and the presentations, and I yield the floor back to our chairman. Kevon?
Thank you, Jeffrey and Juan and other committee members for the good questions and for the good discussion. This was very productive. We will need, I need to make one closing remark, and then when we close it out, committee members will need to move expeditiously over to closed session without a break at this point. But so thank you again for this productive meeting. I do want to say in closing, very importantly, to Linnea and the team, that we look forward very much to receiving the remaining portions of this context item, hopefully by the end of March, or at the very latest, the first week in April, so that we can do our part to prepare the board ahead of the May meeting. So thank you again, and with that, this